Formative exercise 2.3, question number 1. If xy minus 2x squared equal to 3, show that x squared multiplied the second derivative plus x multiplied the first derivative is equal to y. To find the first and the second derivative, we need to let the y to become the subject of the equations. Therefore, xy is equal to 2x squared plus 3. Then y is equal to 2x squared over x plus 3 over x, which is going to be 2x plus 3 over x. Or I can write this as 2x plus 3x to the power of negative 1. So here the first derivative will be 2 minus 3x to the power of negative 2. Or I can write this as 2 minus 3 over x squared. Now, from the first derivative, we're going to find the second derivative. It's going to be negative 3 times negative 2, which is going to be positive 6x to the power of negative 3, which is the same as 6 over x cubed. So, now we want to show that this is equal to y, which is 2x plus 3 over x. So, this is equal to x squared multiply the second derivative, which is going to be 6 over x cubed plus x multiply the first derivative, which is going to be 2 minus 3 over x squared. So simplify this. This is equal to 6 over x plus 2x minus 3 over x. Next, we're going to get 2x plus 3 over x, which is the same as the y. Questions number 2. Finds the value of the first derivative of f of 1 and the second derivative of f of 1 for each of the following functions. So here the first derivative will be 3 minus 6x squared. So here when the input is 1, then the x here we're going to substitute it with 1. Therefore, this will be 3 minus 6, which is equal to negative 3. As for the second derivative, so based on the first derivative, we're going to get negative 12x. So next, substitute here the x with 1. Then the answer is negative 12. Questions B. So first, we're going to expand this. 5x cubed minus 3x squared. Then for the first derivative, it will be 15x squared minus 6x. Next, substitute the x with 1. This is equal to 15 minus 6, which is 9. And for the second derivative, it will be 30x minus 6. To find the value, substitute x with 1. This is equal to 30 minus 6, which is 24. Question C. So this I can write as x cubed over x squared plus x over x squared. Simplify this, then we're going to get x plus 1 over x, or x plus x to the power of negative 1. Then for the first derivative, it will be 1 minus x to the power of negative 2, which is the same as 1 minus 1 over x squared. To find the value, substitute x with 1. This is equal to 1 minus 1, which is 0. Then for the second derivative, it will be negative 1 times negative 2, which is going to be 2x to the power of negative 3, which is the same as 2 over x cubed. Then to find the value, substitute the x with 1. Then the answer will equal to 2. Question number 3. If f of x equal to square root x squared minus 5, then find the first and the second derivative when x equal to 3 and negative 3. So for the square roots, I can write this as x squared minus 5 to the power of 1 over 2. Then for the first derivative, it will be 1 over 2 bracket x squared minus 5 to the power of negative 1 over 2. Then differentiate the terms in the bracket, which is going to be 2x. So here we can cancel for the 2. This is equal to x bracket x minus 5 to the power of negative 1 over 2. Or I can write this as x over x squared minus 5 to the power of 1 over 2, which is the same as 1 over square root x squared minus 5. When x is equal to 3, then substitute the x here with 3. This is equal to 3 over square root 4, which is the same as 3 over 2. Next, using this form in the first derivative, then we're going to find the second derivative. Here we're going to use the product rules. So this will be the u and v. First, copy the u, then differentiate the v. This will be negative 1 over 2 bracket x squared minus 5 to the power of negative 3 over 2. Then differentiate the terms in the bracket 2x plus copy the v, x squared minus 5 to the power of negative 1 over 2. Then differentiate the u, which is 1. So here we can cancel for the 2. Then we're going to get negative x squared over x squared minus 5 to the power of 3 over 2 plus 1 over x squared minus 5 to the power of 1 over 2. This is the same as negative x squared over square root x squared minus 5 to the power of 3 plus 1 over square root x squared minus 5. So when x is equal to negative 3, then substitute the x with negative 3. This will equal to negative 9 over 8 plus 1 over 2, which is equal to negative 5 over 8. Question number 4. If a equal to t cubed plus 2t squared plus 3t plus 4, finds the value of t such that the first and the second derivative are equal to each other. The first derivative will be 3t squared plus 4t plus 3. As for the second derivative, it will be 6t plus 4. Next, this is equal to this. Then we're going to get a quadratic equations. To solve this, first we're going to write this in general form. Then we're going to get 3t squared minus 2t minus 1 equal to 0. Using factorization, we're going to get 3t plus 1, t minus 1 equal to 0. Then the value of t will be t equal to negative 1 over 3. Another one will be t equal to 1. Question number 5. Given the function g of x equal to hx cubed minus 4x squared plus 5x, finds the value of h if the second derivative of g of 1 is equal to 4. The first derivative will be 3h x squared minus 8x plus 5. Then the second derivative will be 6hx minus 8. So when the input of the second derivative is 1, then we're going to substitute the x here with 1. Next, we're going to get 6h equal to 4 plus 8. Then h is equal to 12 divided by 6, which is equal to 2. Question number 6. Given f of x equal to x cubed minus x squared minus 8x plus 9. Finds a the value of x such that f prime of x equal to 0. The first derivative will be 3x squared minus 2x minus 8. And this is equal to 0. This is a quadratic equation. To solve this using factorization, we're going to get 3x plus 4, x minus 2 equal to 0. Then x is equal to negative 4 over 3, or x is equal to 2. Questions B. find the second derivative of f. It will be 6x minus 2. Question C. Finds the value of x such that the second derivative of f is equal to 0. This means 6x minus 2 is equal to 0. 6x is equal to 2. Then x is equal to 2 over 6. Simplify this, then we're going to get x equal to 1 over 3. Question D. Finds the range of x for the second derivative of f less than 0. This means 6x minus 2 less than 0. 6x less than 2. Then x is less than 2 over 6. X is less than 1 over 3.